Hi, my name is Alaric and this is my submission video for Project 2 with Dr. Osbe, summer 2026. Starting off, we're over here in ANSYS workshop. We're going to start here by dragging over here Fluid Flow Fluent, over here to one of these standalones. First thing, we're going to go to geometry. You're going to right click that because we're going to be working on 2D. So we're going to go over here to properties. We're going to change this analysis type from 3D to 2D. Close out of that. And then don't double click geometry. We're actually going to right click and go to design modular over there. Wait that to load in. Over here, once it's loaded in, you see down here it says ready. So we're going to go to the XY plane, click over here in the Z just to get it straight. We're going to start off by creating our geometry. So we're going to do rectangle. I like to start in the origin, it makes it easier. So just over here, extend it. Shape doesn't really matter. Over here now for dimensions, we're going to set our height and length. We're going to click general over there, push this up, push this to the side. And then per our project, our length actually has to be 1 meter. Our height, we get to choose. We decided to go with 0.1, just make it a lot easier, not too big since we're just trying to get as accurate as a boundary as we can. Zoom in over here just so we can see it. Then we're actually going to make this into a surface. So we're going to go over here to concept, surface from sketch. Over here in our XY plane, we're going to pick our sketch, make sure that gets highlighted, and then you're going to apply, making sure everything's good. Now we can generate that. There we go. Everything's good here. We can minimize. Over here to update, making sure this is ready, and we get a green check mark. That looks good. Now we're going to start our mesh. Okay, now that our mesh is fully open, first thing we're going to do, we're going to hit Control E so we can first, we're going to set our names to our layers. We're going to over here pick the top layer, create name selection. ANSYS uses keywords so that it knows what type of wall it is or shape or whatever. So over here, we're going to set a top to our far field. The bottom is actually going to be our flat plate, which is what we're going to be calculating our boundary layer on. Over here to plate. And there over here to the left is going to be our inlet. And over here to our outlet. And if you forget to put this, just go back because then hence this isn't gonna do it right. Like it's not gonna know what it's being calculated. Oh, wait, spelled that wrong. I'll fix that. There you go. Just delete this last one. All right. Now we're gonna go over here, name selection. We're gonna check everything's good. Yep, everything looks good. All right. Now we're gonna start a meshing process. You're gonna over here, go right click on mesh. First, we're gonna start up in our face mesh just to get a baseline. Click on your geometry. Over here in geometry, you're gonna hit apply, making sure everything's good. Yep. Now we're gonna generate that. Should only take about like 1 second. Yep. Now that we have that, if we check our mesh, you can see there's some huge squares. This is gonna be horrible because it's not gonna be that accurate. So we want to add more. So we're gonna right click on mesh here, insert. We're gonna click over here to sizing. We're gonna hit Control E again just so we make sure we're on edge. First, we're gonna start with bottom and top. So we're just gonna pick both of those. Over here to the left, we're gonna hit apply, making sure those two edges are picked. For a type, we don't want to use element size. We want to use number of divisions. And us, we found what worked best was 50. Making sure there, see all the evenly spaced lines. Then our capture curvature, we actually don't want to use this. And our behavior, we want it to be hard. And then making sure everything looks good, we're going to generate that. Again, should only take about a second. Now, if we check our mesh again, it's looking a lot better, but it still isn't going to be good because since we're calculating a really small boundary layer down here, we want to make it as fine as possible. So we're going to keep adding. We're going to go to sizing, insert. We're going to start over here in our inlet. So just picking that one side, you're going to apply it. Again, you're just going to change this to number of divisions. We did 60 for this one. And then you can see over here, you can see all your fine lines. all evenly spaced. Again, you're going to do capture curvature to no, change your behavior to hard. And this will be better, but as you can see, our boundary is going to be really small down here. So you don't want this to be evenly spaced. So we're actually going to change our bias type to this top one here. We're going to pick this line and then we're going to hit over here. For our bias factor, we're going to do 70. And then once we do that, see how this is now more space on the top and more tight on the bottom. That's going to give us a lot better mesh. So we're just going to generate that. Wait for that to mesh. Now, if we look at our mesh, looking a lot better, but we still have to do this other side. So we're going to insert a new sizing. Now we're going to do the outlet, which we're pretty much just going to mirror the other side. So changing our number of divisions, we're going to set it to 60. Our capture curvature, we're going to say no, behavior hard. And then again, our bias type, we're just going to change it to the top one. We're going to define this corner. Then we're going to do 70 again. But now if we look over here, you can see it's reverse. It's finer in the top, but spaced out on the bottom. So to fix that, we're actually going to go over here to reverse bias. And we're going to pick this edge and we're going to hit apply. Once we do that, we can see how it just fixes itself. Now it's more finer on the bottom, more spaced out on the top. Making sure everything looks good, we're going to generate that. Now that that is done, we can go over here and click our mesh again. And this is a lot better. See how it's spaced out on the top and a lot finer on the bottom. That's going to make us calculate boundary layer and get a bunch of accuracy. Now that that all looks good, we're actually going to minimize. Over here, you're gonna right click on mesh, you're gonna update it, making sure you get that green check mark. Okay, all good there. Now we can start on our setup. You're going to see this window pop up. You're going to click double precision and the solver processes. You're going to pick tools will work best. And then you're going to start it up. Wait for that to load in. Cut here. Just wait for it to load in. Now that we're loaded in, see how before I put the inlet and outlet, that's how ANSYS knew to add these arrows to make sure this is the inlet, this is the outlet. Our mesh is here looking good. Me personally, I like to start by setting my residuals. So you're gonna go over here to results on this top bar, click on residuals. I like it to be accurate, so I make this 1.10 or 1 to 10, 1 times 10 to negative 6. You're just gonna add 3 zeros to this. Making sure that looks good. You're gonna hit OK. I like to check it twice, so just click on that, make sure it's good. Yep. Over here, we're gonna start on our model. Our viscous, we're working on laminar, so you're gonna double click that, set it to laminar, click OK. Make sure it says laminar, everything's looking good. Then we're gonna our materials, we're working with fluids, specifically air. Per our project, we're supposed to use 1.2 density and viscosity 1.8 times 10 to negative 6. Making sure it looks good. You're going to change and create. Close. Again, I like to double check, so just double click it again. Everything looks good. Close out of that, close out of this. Our cells and conditions good. We're going to double click on boundary layer here, on boundary conditions. Starting off on our far field, we actually want this to be a symmetry, just to copy the bottom wall. Oh, sorry. Change out of that, change it to type symmetry. Click apply and close. Now we're going to go to our inlet, which is going to be working with our inlet velocity. Per our project, our inlet velocity has to be 2 meters per second. So change right here your velocity magnitude to 2. Click apply and close. Again, I like to double check, so just double click. All looking good. Surface, body is going to be an interior. Our outlet is going to be a pressure outlet, and our plate is actually going to be a wall. Double click this just to make sure that you're set to stationer one and no slip condition. That was good. Apply and close. We're good on our boundary conditions. Over here, we can check our reference values just to make sure all our values are correct. Calculate compute from inlet. Everything there looks good up to what our project requires. We're going to go over here down to solutions to our methods. We're actually going to change the scheme from couple to simple just to keep everything good. And then everything looking good. Yep. Now we can initialize the system. We're actually going to do standard initialization. We're going to compute from our inlet, which our gauge pressure should be 0, velocity at x should be 2 meters per second. Our y is actually going to be 0. So we're going to change that. Looking good. We're going to initialize that. Make sure we initialize. Yep. All good. Now we can actually run our calculations. Over here, making sure everything's good. We're actually going to set our iterations to 10,000 just to get all the accurate numbers. And then you're just going to hit calculate. You should see your graph developing over here, making sure everything looks good. Yep. Now we just wait for that to be done. Cut here. And no stitches. All right, now that our calculations are complete, we can hit OK here. That graph that was being created, you can watch it over here, see how everything looks good. Now, for our project, we are required for part A to get our velocity with vectors and pressure contours. So we're going to start that now. To do that, you're going to go over here to graphics, double click on contour. We're going to create our first contour, which is going to be our velocity contour. It's going to be a contour of velocity, making sure it's velocity magnitude. You're just going to save and display that. We can see over here how our boundary layer starts off small, slowly developing until it reaches steadiness, and then it just continues all the way through to the other edge. Looking good there. All right. And now here to actually set our vectors, we're going to go over here down below contours to our vectors, double clicking on that. This is going to be our velocity vectors. Again, vectors of velocity colored by vectors. Yep. And then we're just going to save and display. Over here, we can see again how the boundary layer is developing. It starts so small and then slowly starts speeding up. That's how you can see the vectors getting higher all the way until it just gets steady and stays the same height. Looking good. Now we are required to show both of them at the same time so you can close out of these. To do that, we're going to go over here to scene. So you're going to double click on scene. We're going to make this our velocity scene. Get rid of that one. And then title is just going to be velocity scene. Same thing. And then we're going to click both our contour and our vectors. If you hit save and display, the actual contour takes over. So over here at transparency, you can set this like halfway, 60% should be good. Save and display. Now here you can actually see both of them, seeing how the boundary layer slowly starts in both of them, how the velocity is all the way to the end, and then it just slowly develops, going up to its full boundary layer height. Yep, looking good there. Now that we have that, part A still requires us to do a pressure contour. So same thing, you're just going to go to contours, creating a new one. This one's going to be our pressure contour. First, we're going to do contours of pressure. First, we're going to show the static pressure, how it just starts up here where the boundary layer starts and then just gets even all the way through. We can also show here our dynamic pressure contour. Same thing, started developing on the front here, and then slowly just gets developed until it just stays the same all the way to the end. And we can actually see our total pressure here, which would practically look about the same as the dynamic pressure. Starting out small here at the start, slowly developing all the way through. And yeah, there's part A. Going back to our assignment, part B requires us to create a velocity profile specifically at 35 and 75 centimeters. And then using that, we can determine our boundary layer thickness, which we're going to compare to our theoretical values, which I have in Excel, which I'll show you in a second. First, we're actually going to go over here to surfaces. We're going to right click on that. We're going to create new. We're going to pick line rake. This is where we're actually going to set our points. So we're going to title this our X at 0.35. Of course, our X point's going to be at 0.35, 0.35, and our Y1, we're going to set this to our total height, which is 0.1. We're going to create that, making sure we're here below surfaces. Let's create. Yep. Now we're going to create our 0.75 for our point at 75 centimeters, changing this to 75, this one to 75, our height to 0.1. We're going to create that, making sure it's there. Yep. Now we're going to create our actual plot. So we're going to go to your plots, double click on XY plot. I'm going to title this our velocity profile. Oh, spelled that wrong. There we go. Our y-axis is going to be our velocity magnitude. We're not going to do positioning on X. We're going to order points. Our X is going to be just our mesh. And then we're not going to do X coordinate. We're actually going to do Y. And then we're going to pick our 2 points we just created and making sure everything looks good. Over here, you can check write to file. This is how you can export your values. But for the sake of the video, I'm just going to show you the plot. So we can see over here, looking good, or you can see our actual thickness all the way until it reaches 2 meters per second, which would be our highest boundary layer thickness. Now that we got that plot, I can show you our Excel to compare our values. Over here on this side, we can see our theoretical values at each point, but specifically we want to see 0.35, which would be right here. This is our theoretical boundary layer thickness at 0.008. And then at 75, our theoretical over here was 0.11 meters. These are all in meters. And then over here is our actual ANSYS values, which we exported. This is our Y values, which is the Y values on the height. And then this is our velocity values. So right before it reaches, over here on the left, we can see our ANSYS, which will be our Y values. And on the right is our velocities. So right before we reach 2 meters per second, which is where inlet velocity was, we can actually see our boundary layer thickness. For our ANSYS, our height was 0.006 for our 0.35. And then for our 0.75, right before it reaches 2 meters per second, we actually get 0.008. And then over here is where we compare them, which you can see over here are comparisons of both of them. And our percent error for the 0.35 is actually 23% error, and for 0.75 meters, it was 30%. And then over here is our graph comparing both of the 0.35 and 0.75, so the velocity and the height. And yep, there we go. That's part B. That's it for me. Now my partner is going to show you part C and part D of the project. Thank you.
Hello. Now, going back to the um, fluent. So let me see right here. Okay. So, so back here. That was the wrong one. Okay. So now we're here. What we're gonna do is we need to plot the wall shear stress and skin friction. So what we're going to do is go to XY plot. We're going to click on the XY plot and we're going to change here to wall fluxes and wall shear stress. And we're going to click on the plate. And so that is where we're going to get our data from. And as you can see, there's a very good line, how it's supposed to be going down, down, and then constant. And now would be as I can show you the Excel sheet, and we go on over to the shear value. So here we have the Reynolds number and the Y values, and then the shear stress. So what I did is I times by 1,000 to put it in megapascals. So they're both in megapascals. And as you can see, if you scroll down, this is our graph right here for the shear stress, which is theoretical. And as you can see, they line up pretty good. And here on the left is the megapascal and megapascals, and down the bottom is the Y values. And as you can see, to create the graph, you just calculate, you take all three top of the titles, and then you drag down and copy, and you end up with the graph by inserting and recommended charts, and you click the chart that you want. Now, back to Yep. Now back to the solution plot. Now all that's different is you change this to skating friction coefficient, keep it on plate, and then save the plot, which now looks like this right here, based on the position of the plate. And then we um, go back to the Excel sheet. And as you can see right here, same thing, Y value, skin friction coefficient, and the theoretical. So we scroll down once again. And as you can see, right here, this is good. Only reason this is bad was because of the mesh, but everything should be, yeah, pretty close. In terms of percent value error, I'm pretty sure this one was around 20%, and this one was also around 20%. So last thing is to um, oh yeah, and also in this, the if you look at the value here in the theoretical, um, it should be pretty close. And then oh yeah, and then now we're on D, so get the drag coefficient. So what we do is you go back to ANSYS, right? Close this. So what you want to do is go to report definitions, right click this and click new, click force report, and click drag. So now once you have drag, you check drag coefficient, which is already clicked for you. Click on plate, press OK and compute. Oh, I did not compute it. My bad. Let me new force report, drag, plate, compute. And as you can see here, the coefficient, the drag coefficient value right here, and as you can see, that matches up with the Excel value up here. So this is the theoretical value compared to the ANSYS value, and you get a percent error of 14%. That is all the parts done with their comparison to theoretical values. Thank you for watching, and that is our project. Oh.